Okay, so how are we going to define the true, magnetic, and assumed bearing of a line? Okay, so I will discuss the difference between the three types of uh, directions of lines here in terms of reference meridian. Okay, so let me discuss in terms of, or by giving you the illustration. So we have here line AB. So what is, or how are we going to define the true bearing, the magnetic bearing, and assumed bearing of this line? Okay, so if you have this point AB, so I will draw the meridian at point A. Okay, so let me say this is my true meridian. Okay, true meridian at A. So this is my true north. And of course, this is my true south. Okay, so the angle from the true meridian is called the true bearing. Okay, bearing true. Or that is true bearing. Okay, so if there is a, or an assumed meridian, kunyari yung assumed meridian mo is located here. Okay, somewhere maybe here. This is the assumed meridian. Because assumed meridian, we do know, it might be in that direction, in this direction, or it might be, usahay, it coincides with the true meridian. Then it's no problem to get with what is a true bearing of a line. Okay, so in this case, let me illustrate that the assumed meridian does not coincide with the true meridian. So I'll call this one as my assumed north, and of course this is the assumed south. Okay, so the angle between the assumed meridian to the line, like this angle, this is also called the assumed bearing. Okay, so here let me write BA, or beta A, is the bearing assumed. Bearing of line assumed, or assumed bearing of the line. Okay, so you have assumed. Okay, another, if I will draw another meridian that does not also coincides with the true meridian, and I will call that meridian as magnetic. For example, the magnetic meridian is here. Let me choose another line, another color. Okay, let me choose just red. Red are not true meridians. Okay, so for example, I will have the magnetic meridian here. It's on the east. Okay, just example. So of course, this is my magnetic north, and this is magnetic south. So the angle between the magnetic meridian and the line, this amount, okay, between magnetic meridian and the line is called the magnetic bearing. Okay, so I will call it BM. Okay, so to emphasize, B sub M is the magnetic bearing of line. Okay, so just shortcut, bearing magnetic. Okay, so we were able to define what is the difference between true bearing, assumed bearing, and magnetic bearing. Now, so just look at where the angle is referred to, where the angle is being reckoned. Okay, so for the true bearing, it is the angle between the true meridian and the line. If it's bearing or assumed bearing, it is the angle between the assumed meridian and the line. If it is magnetic, then it should be between the magnetic meridian and the line. Okay, so now what is true azimuth true magnetic azimuth and assumed azimuth. So, syempre, no, if we have the true bearing and then if you convert that into azimuth, ang mangyayari, you will get a true azimuth. Okay? So, you will also get the true azimuth. Okay? Likewise, if you convert assumed bearing to azimuth, you will get the assumed azimuth as well. Okay? Also, if you convert magnetic bearing to azimuth, then of course, you can get the magnetic azimuth. Okay, so using the previous knowledge that you have or the previous lessons that we discussed, so you can convert bearing to azimuth and vice versa, then you will get this information. Okay. Okay, so our previous lessons discussed the different types of meridian. So here, we will be solving problems that involves those meridians. So for number 1, we have the assumed bearing of a line is north 45 degrees west. If the assumed meridian is oriented at 10 degrees east of the true north, compute the true bearing of a line. Okay, so in solving problems that involves different types of meridians, it is always advisable to make a sketch. Okay, so the first thing that you are going to do is to draw the true meridian. Okay, so for example, this is the true meridian. Oh, it's not working. Okay, that is the true meridian, or this is the true north. Okay, and of course, the line perpendicular to the true north, this is your true east. And of course, this is your true west. And here is true south. Okay, so once you have the true meridian, the next thing you are going to do is you have to plot the assumed meridian, or it could be okay, so we have here the true meridian. So after drawing the true meridian, the next thing you are going to do is you have to plot the other meridians. Okay, so in here, what I mean by other meridians, so meridians other than the true meridian or the geographic meridian. So here we are given the assumed meridian. So meaning to say, we are going to plot the assumed meridian. So where is the assumed meridian? So it is stated here that it is oriented 10 degrees east of the true north. So meaning to say, it is around 10 degrees here, so it's somewhere here. Okay, so you have that. Let us just exaggerate this drawing. So you have this true, or this is the assumed meridian, or I call it as assumed north. Then of course, the prolongation down is the assumed south. Okay, and the angle between is 10 degrees. Okay, why is it here? Because of the problem that it's 10 degrees east of true north. So meaning to say, 10 degrees from the true north to the east. Okay, so this is the 10 degrees. So after plotting the true meridian and also the other meridians in this problem, the assumed meridian, the next step you are going to do is to plot the other given, or that is the line. So we are given here, assumed bearing of a line is north 45 degrees west. So where is the 45 degrees west, or north 45 degrees west, and it's assumed. Okay, so if this is your north and south, so the line that is perpendicular to that line, we will call that, of course, as the we have the assumed east and assumed south. Assumed east and assumed west. Okay, so this is your assumed west, and this line, or here the branch, is assumed na east. Okay, of course the angle between here is also 10 degrees. Now we have the bearing of line northwest, so north 45 west, so meaning to say from north, then in the northwest quadrant, that is 45 degrees west, that is the location of the line, so it is somewhere here. No, so this is 10, so 45 is somewhere in the middle of this quadrant, assumed north and assumed west. So let me draw the line in red, so I'll call the line okay, so this is line. Okay. And having a bearing of north 45 degrees west. So where is the 45? Asa man magsugod ang 45? So it should be from the assumed north, because of the statement that is assumed bearing. So it should start with, or it should recon from the north branch meridian. So you have 45 degrees. Okay, that is 45 degrees. Now, the given, or the required actually, is the true bearing of a line. So in this problem, true bearing, when we say true bearing, it refers from the true meridian. So from this figure, we can say that our true bearing of the line is measured from this point, or this angle actually. Okay, so this is the required, wherein beta is basically the true bearing. Okay, so given this illustration, we can finally solve what is beta. Beta, based on this illustration, is our true bearing. So we have here, if this is 45, for the angle from here, or the angle between this line is 45, and the angle here is 10 degrees. So we can say that beta is equal to 45 minus 10. Okay, so beta is equal to 45 degrees minus 10 degrees. So therefore, we can say that beta, or the bearing, or the true bearing of a line, is 35 degrees. The direction, it is within the northwest quadrant of the true north. So you can say northwest. So this is the final answer. Okay, so to sum it up, to solve problems involving different types of meridian, so the first thing you are going to do is you have to plot the true meridians. Next is you have to plot the other meridians depending on the given. Then after that, you have to plot the line. Where is the line located? Then from that sketch, you can tell how to compute the required quantity. In this case, how to compute the true bearing of a line. Okay, another problem. The true bearing of the assumed meridian is south 5 degrees west. The said assumed meridian was used to determine the direction of a traverse line during the survey. If the bearing of a line was found to be north 50 degrees east, compute the true azimuth. Okay. Okay, so first things first, you have to draw the true meridian. Okay? So aron di mawala, you have to draw the true meridian. Okay, so this is your true north, and of course here is true south. The line perpendicular to the line, this line is this is true east, and this is the true west. Okay, after sketching the true meridians, we draw now the other meridians. So in here we are given, or it mentioned, now the problem mentions about assumed meridian, which is south 5 degrees west. So it is given, so the bearing of the assumed meridian, which is true bearing, meaning to say the 5 degrees should refer from the true meridian. Okay, and that is the location of your assumed meridian. So where is south 5 degrees west? Okay, take note that it's true. Okay, where is south 5 degrees west? So it is somewhere here. So let me draw the line. This is the south. Okay, and we have 5 degrees. Now, since this is the meridian, this is the assumed meridian, so I will call this one as assumed south. And of course, if I will extend that line going in that direction, the other branch, other end, so of course this is the assumed north. Now, so we already plotted the assumed meridian. So the next step you are going to do is you have to plot the line. Okay, the line here is stated that the assumed meridian was used to determine the direction of a traverse line during the survey, and then the bearing of a line was found to be north 50 degrees east. So meaning to say, this is the bearing reckoned from the assumed meridian, not from the true meridian. Okay, so we have, where is 50 degrees east? So it is somewhere in this quadrant. Okay, you have this line that is 50, it's somewhere here. Okay, so it's like that, and that is the line. Okay, so the line goes in that direction, and okay, and then we are given 50 degrees northeast. So where should we reckon the 50 degrees? So of course we will reckon it from the assumed north, because it is mentioned here that the said assumed meridian was used to determine the direction of the line. So meaning to say, this north 50 degrees east is the assumed bearing of the line. So dili po ka maggukod, no? So we have to reckon from here. Okay, gikan siya sa assumed. So of course it should be from here. Okay, so you have 50 degrees. Okay, and let me draw the line. So the line perpendicular to this red line, of course, that is also the assumed east and west of the meridian. Okay, so it is still within the line, or quadrant rather. So this is assumed east. Okay, so you have 50 degrees. 50 degrees. Okay, so if this is 5 degrees, this is also 5. Okay, and we are required to compute the true azimuth. So what is true azimuth? True azimuth reckoned from the south. Okay, so it would be the angle from here. It would be the angle from here. Let me draw here, towards the line in clockwise direction. So this is the angle that we required to solve, alpha. Alpha is the azimuth. or the true azimuth of a line, because it reckon from the true south. Azimuth of line, or that is true azimuth of line. Now, if you are going to use this illustration and then directly solve the azimuth, it would be difficult for you because you will involve several angles. No? So if you are asked to compute azimuth gani, no, it is advisable, or I always advise to compute first the bearing, and then from the bearing you compute the azimuth. But however, you can you always have option to do, no, like to do some mathematical operation, but usahay maglibog man mo, so I rather advise you to compute first the bearing, because bearing is an acute angle and it's easier for you to solve, and then it's easier to solve using this illustration. Okay, so what is the bearing first? Although we are required to solve the azimuth, but as what I have said, it is better to compute first the true bearing, and then from the true bearing, convert that to true azimuth. Okay, so where is the true bearing here? So if this is the line, true bearing is basically this amount. It reckoned from the true north, okay, or the true meridian. So this is beta. Okay, so beta here is the true bearing. Okay, once we know the true bearing of a line, we can compute the true azimuth of the line. So in this illustration, beta is basically the sum of 50 and 5. Okay, that is 55. So beta therefore is equal to 50 degrees plus 5 degrees. Then you can get 55 degrees. Of course, that is in the north east quadrant. That is beta. Okay, so this is still the true bearing of a line, but we are required the true azimuth. So you need to convert the true bearing and into the true azimuth. Okay, so of course, therefore alpha is equal to, using the previous topic that we had, so we have, it is in the northeast quadrant, and it would be 180 plus 55. So you have 180 degrees plus 55 degrees. So it gives you 235 degrees. So this is the azimuth of, or the true azimuth of the line. Okay, so if you have the assumed bearing and then convert that into azimuth, yung mangyayari din is you will get the assumed azimuth. If you have this true bearing, you will get also the true azimuth. Okay, so depending on the problem, no? Okay, so true to true, assume to assume, and then it could be magnetic to magnetic